PMO 2022 Philippine Mathematical Olympiad, day 2, problem number 6. For having next videos, subscribe, turn on the bell, like the video, and you can send message through my WhatsApp number. Okay, problem number 6 is the following. In triangle ABC, let D be the point on side BC such that AB plus BD equals DC plus CA. The line AD intersects the circumcircle of triangle ABC again at point X that is not equal to A. Prove that one of the common tangents of the circumcircles of triangle BDX and CDX is parallel to BC. Okay, if we draw the triangle, it would be like this. So let me tell you what I want to do. I consider D as the thing here. We know AB. Let me write it here. I know AB from the assumption of the problem plus BD equals AC plus CD. Now, if we draw X, I consider BXD, this angle. I draw internal angle bisector and suppose intersect this circumcircle of BDX at L. Then I draw a tangent to this circle at L through L, and I consider it intersect this at T. Now, let me tell you at first, this line shows what? It is, I said, we know this angle equals this angle, so because it is C, they are equal, they see the same arc. So I can say, if I draw the perpendicular bisector, if I draw the angle bisector, internal angle bisector, each of the angles equals C over 2. Now, because this one and this one see the same arc, so this one is also C over 2. This one and this one see the same arc, so this one would be C over 2. Also because this is tangent, so equals half of this arc equals this. So this one equals also C over 2. So we conclude that this is parallel to this. Now, I do the same thing for this angle, and I suppose that if, for example, this one, if I draw tangent to this circle through K, we can prove similarly that it is parallel to BC. So if I prove that the T, for example, it is in T prime. If I prove that T equals T prime, then this is these two parallel lines, because both of them are parallel to BC, they have common point T. And then we can say this is one line, because when two parallel lines have one common point, they are same line. So then I can say LTK is our common tangent because it is tangent to this circle, and also parallel to BC. So our purpose is to prove that YT equals T prime. Now, let's find DT. So if we prove DT equals DT prime, then the problem will be solved. Now, let's see what can we say. So this angle is X because of this circumcircle ABC. It's see this side, this arc. So I can say it is X. Similarly, I can say it is Y. Now, I want to find DT. So DT over LD, and at first I consider BDLD with sine rule. Then I consider LD DT. So I find dt. So let's consider BD over LD by sine rule. BD over LD equals sine. It is C over 2, C over 2, so it would be 180 minus C over LD. LD is opposite to angle C over 2, so sine C over 2. So here we can say, okay, it would be sine C over sine C over 2. And we know sine C is 2 sine C over 2 cos C over 2. Over sine C over 2, we can cancel, and it would be 2 cos C over 2. It was BD over LD. Now, let's see what we have now. C over 2. We want to find TD. TD over LD. it BD over LD was in triangle BDL. TD over LD is in triangle TDL. So for LD, TD over LD. TD is the angle correspond to that is C over 2, so it would be sine C over 2. And LD, we should find LD. We know that it is parallel this angle. Let me draw with another color. So this angle equals this angle, okay? So this angle, because they are parallel, we proved. And this angle equals what? It is exterior angle. It's B plus Y. Okay, so we can write this angle equals sine B plus Y. Let's check it again. Sine this one we want to find because opposite LD. This one because they are parallel equals this one, LT parallel to BC. And this one is exterior angle of ABD. ABD, so it would be B plus Y, sine B plus Y. Now we can find TD. How? We say, okay, TD is LD times sine C over 2 over sine B plus Y. Now, the next thing we want to find, LD. LD is what? Or let me tell you, we can also do something. Multiply these two terms. I think it would be easier. If you multiply, you don't need to write this. If you multiply these two terms, so TD times BD, no, we should divide. Okay, so let's consider TD like this. Then we want to find LD in terms of BD. BD over LD is 2 cos C over 2. So LD is what? LD is BD over 2 cos C over 2. Now, if I replace, then I conclude TD equals BD sine C over 2 over sine. Let me check. If we replace BLD here, it would be BD and also sine C over 2 cos C over 2, 2 cos C over 2 times sine B plus Y. Okay. Now I want to prove why dt prime is exactly this. So if I want to find t prime d, similarly, I can say it is equal to CD sine B over 2. So similarly, over 2 cos B over 2, B and C would change. Sine C plus Y. C plus X, sorry, because X. So you can, if you think that it is not equal to this, you can find again dt prime, consider this point t prime, and exactly by these steps here, try to find t prime d, and you would reach cd sine b over 2, 2 times cos b over 2 sine c plus x. Now, let's copy. We want to prove that these two terms are equal. In this page, okay, we want to prove why they are equal. So let me write it is this. Let me take it here. Okay. Now, before proving this, I want to tell you something. BDD is an important point. Why? Because if we consider a triangle ABC, and if we have a circle, we want to find the length. Let me explain for you. There are many things like this you should memorize. There are around, I think, 40 formulas that are important and you need to memorize. One of them is this. When you have, for example, BE, we want to find it. We know this one equals this one equals this one, and this one equals this one. So you can call this one X, X, Y, Y, Z, Z. So we know X plus 2X plus 2Y plus 2Z equals perimeter, or 2 times semi-matter. So x plus y plus z equals s. So for example, if you want to find x, x equals s minus y plus z. Y plus z is what? A, B, C. So is s minus a. Similarly, you can say y equals s minus c and z equals s minus b. It is the first thing I wanted to say. The next thing that I want to say is that when we have something like this, let's consider smaller one. Okay, now if I consider it is a, b, c, d, I want to find this. I know it is equal to this. Here you can consider x, and this is equal to this because because tangents from one point to this circle, it is b, it is c. So you know a plus b plus c is what? Is perimeter, or 2 times s. You can replace a with x plus y plus b plus c equals 2 semi-matter. So you can say x plus b, y plus c equals 2s. X plus let's consider x plus c, rearrange like this. X plus c, y plus b. So x plus c is what? Is, for example, AL equals AL. We know AK equals AL because there are two tangents from point A to this circle. So you can conclude what? You can conclude from these things AK equals AL equals S. So X plus C is S, Y plus B is semi-matter S. So you can say X is S minus C, Y is S minus B. And if you pay attention, in the assumption of the problem, it says AB plus BD equals AC plus CD. This D is the D of the problem. So it means what? It means C plus BD equals B plus CD. We know sum of C plus BD plus B plus CD is what? Is 2S. So each of them would be S because they are equal from the assumption of the problem. So BD equals S minus C. And if you pay attention here, also BD is S minus C. So the D of problem is exactly this point. Now we want to use these two things to solve the problem. Here we want to prove this. BD CD sine C over 2. Now I know I, if I consider I and draw a perpendicular, it would be exactly this point E. Because if you consider the center and if you draw perpendicular, you connect I center to the tangent in the point that it is tangent, it is perpendicular. So I can say this E, this is Z again. For example, Z is S minus B. Now I want to use this. So here I want to prove BD times sine C over 2 CD times this, they are equal. I know B plus Y is what? B plus Y is D2 because of exterior angle. And C plus X equals what? D1. So what can I say now? I know that I want to, I know BE is S minus B because I proved, and also CD is S minus B. So if I want to say, I can say BD sine C over 2 equals CE sine C over 2. So BD times sine C over 2, because we said BD is S minus C, and also we said CE is S minus C. CE is what? C here, Y. It is equal to S minus C. Also here, why BD is S minus C? Because BD is this point X, S minus C. So we know they are equal. So BD sine C over 2, you can replace it with C sine C over 2. So C times sine C over 2. Let's see what can we say. So if I consider C, let's do something. Instead of writing this, let's consider, I can say cos C over 2 equals C over Ci. Okay? Now, I can say CE is BD. So it equals BD over CI. So I can conclude CI equals BD over cos C over 2. So BD over cos C over 2. Similarly, I can say BI is CD over cos B over 2. Now, if I replace BD over, you can also, if you want to prove this, you can multiply both sides by 2. BD over cos C over 2 is CI. So CI sine C over 2 sine over sine D2. Why it is equal to BI cos BI. You replace CD over cos B over 2 by BI times sine B over 2 over sine D1. Okay? And also we know D1 and D2, but some of them is 180 degrees, so you can cancel them. It is equivalent. That CI over sine B over 2 equals BI over sine C over 2. And if you consider triangle BIC and use sine rule, CI over sine B over 2 equals BI over sine C over 2. So we prove this, it is correct. And we can conclude it is correct. So TD equals T prime D. So as we said, this is equivalent to sentence of the problem. So we've solved this problem completely.